Have you ever looked up at the night sky and wondered, with all those planets zipping around the sun, why don't they ever just crash into each other? It seems like cosmic chaos, right? A giant game of celestial bumper cars just waiting to happen? Well, the reason our solar system is so stable and not a chaotic mess is actually a beautiful dance of physics, governed by a few key principles. First and foremost, let's talk about gravity. You probably know that the Sun, being the most massive object in our solar system, has a tremendous gravitational pull. It's this gravity that keeps all the planets, from tiny Mercury to giant Jupiter, locked in their orbits. Think of it like a string you're swinging a ball on. The Sun is your hand, and the planets are the balls, constantly being pulled towards the center. But if gravity is always pulling planets toward the Sun, why don't they just fall straight in? This is where the second key ingredient comes in, their velocity or speed. The planets aren't just sitting still. They are moving sideways at incredibly high speeds. When the solar system formed, all the gas and dust that clumped together to create the planets was already swirling. So, the planets inherited this sideways motion. This momentum wants to fling them straight out into space, away from the Sun. So, you have two forces at play: gravity pulling the planets in, and their inertia trying to carry them away in a straight line. The result of this cosmic tug-of-war is a stable, curved path we call an orbit. It's a perfect balance. The planets are essentially in a state of continuous free fall around the Sun, but they are moving so fast sideways that they constantly miss it. Now, what about the planets crashing into each other? Well, space is big, really unimaginably big. The distances between planetary orbits are vast. For example, the distance between Earth and Mars at their closest approach is still about 55 million kilometers. That's a lot of empty room. It's not like they are lanes on a highway right next to each other. Plus, all the planets in our solar system orbit the Sun on roughly the same plane called the ecliptic plane. Imagine a giant flat disk with the Sun at the center. The planets are like marbles rolling in separate concentric grooves. On this disk, while their orbits aren't perfect circles, they're slightly elliptical and they have slight inclinations. They don't cross paths in a way that would lead to a collision. Over billions of years, the solar system has essentially cleared its own neighborhood. In the early chaotic days, there were probably many more small planetary bodies, and collisions were much more common. In fact, our own moon is thought to have formed from a massive collision between Earth and a Mars-sized object. But over time, the stable orbits we see today are the ones that survived. Anything with a wonky, unstable orbit either crashed into something else, was flung out of the solar system, or was captured by a larger planet. What we are left with is this beautifully ordered and stable system. This phenomenon is called orbital resonance. The planet's orbital periods are related in such a way that they gravitationally nudge each other, but in a stable, repeating pattern that prevents their orbits from becoming chaotic and crossing. For instance, Jupiter's immense gravity acts like a cosmic shepherd, helping to keep the asteroid belt in place and protecting the inner planets from potential impacts. So, the next time you look at a diagram of the solar system, don't picture a dangerous traffic jam. Instead, see it for what it is: a grand, elegant cosmic ballet, choreographed by gravity and momentum over billions of years. The planets aren't crashing because they're in a stable, balanced dance within an incredibly vast space, each in its own well-defined lane. It's a testament to the beautiful order that can arise from the fundamental laws of physics. Thanks for watching. If you enjoyed this journey through our solar system's amazing stability, Don't forget to like this video and subscribe for more cosmic curiosities. See you next time.